Hello my dear students, hope you all are fine and safe at your home. Today we are going to discuss about how to calculate the limit of functions. So when we started the concept of limit, that time I explained you limit if any function is there, f of x, limit x tends to a, f of x will exist if its left hand limit and right hand limit both will be equal. So to calculate the left hand limit, what we are doing, we are taking the particular values of a which are slightly less than a. Means we are taking the value in this way, limit x tends to a minus, and like right hand limit means we are taking the values of x which are slightly greater than a, and that we will denote it by limit x tends to a plus. So if both left hand limit and right hand limit are equal, then we will say limit x tends to a, f of x exists. And if the limit exists, it will be equal to f of a. So if any question, if it is given limit x tends to a, f of x equal to f of a, it means limit x tends to a, f of x exists. Which means, yes, left hand limit and right hand limit both are equal. So now we can check how to calculate the left hand limit and right hand limit. So first question is find limit x tends to 0, f of x, find limit x tends to 0, f of x, and limit x tends to 1, f of x, where f of x is given there. F of x is equal to 2x plus 3. F of x is equal to 2x plus 3 when x less than or equal to 0, and f of x is equal to 5x plus 3 when x greater than 0. So now just to check here the values of x which they specified, that is x equal to 0 there. Okay, so when we will calculate this value, limit x tends to 0, f of x. How to check the left hand limit and right hand limit? So now just to check here, what is the meaning of this one? X is less than or equal to 0. So for all the values of x, when you are taking less than 0, you have to select this function. And when you are talking about x greater than 0, then we will select this function. So since here it is given for x equal to 0, the condition is given for that. So when we will calculate the limit at x equal to 0, we will calculate both left hand limit and right hand limit. So just first we are finding the left hand limit. Left hand limit at x equal to 0 means we are taking the values which are slightly less than 0. So when less than 0 is there, then out of these two functions, which function we will take? Yes, obviously we will take the function 2x plus 3. So just write down there, when we are calculating the left hand limit, we will take f of x as 2x plus 3. Now just write down there, limit x tends to 0 minus. This minus sign indicates that we are taking the values which are slightly less than 0. In place of x, what is the function we have? 2x plus 3. So just write down there 2x plus 3. Now you don't have to do anything. Just substitute x equal to 0. What will come? If we will substitute x equal to 0, we will get the left hand limit is equal to 3. This much only you have to do. We have to just check which function we have to take out of these two to calculate the left hand limit and right hand limit. So we got the left hand limit is equal to 3. Now similarly, for calculating the right hand limit, out of these two functions, which one we will take? It is given. If x is greater than 0, then you have to take this function there. So just write down there, f of x is equal to 5x plus 3. Now limit x tends to 0 plus 5x plus 3. In place of x, just substitute 0. What will come the right hand limit? Yes, the right hand limit also will be equal to 3. So what we are getting? Left hand limit and right hand limit both are equal, and both are equal to 3. So directly we will write down there limit x tends to 0, f of x value will be equal to 3. If both the left hand limit and right hand limit, suppose they are not equal, then we will write down their limit at that point does not exist. Clear how to calculate the left hand limit and right hand limit? Okay. So the first part is over. Limit x tends to 0, f of x is equal to 3. Second one is given, we have to calculate limit x tends to 1, f of x. Limit x tends to 1, f of x. Can you tell me out of these two functions, which one we have to take? Limit x tends to 1. X is equal to 1 means the value of x is slightly reaching 1 there. Means it is greater than 0. So out of these two functions, when x is greater than 0, which function is given there? The function given is 5x plus 3. So in place of f of x, we will write down there 5x plus 3. Now just to substitute, x is equal to 1. What will be the value? Yes, we will get limit x tends to 1, f of x is equal to 8. This much only you have to do. I hope this concept is clear. Okay. Now we will check the next question. Question number 2. In question number 2 it is given, evaluate limit x tends to 1, f of x, where f of x is equal to 1 plus x square if x less than or equal to 1, and it is equal to 2 minus x if x greater than 1. Now, it is condition given for x less than or equal to 1 and x greater than 1. So, whenever we are calculating the limit, we have to calculate both left hand limit and right hand limit. So, now first we are calculating the left hand limit. Okay. So, shall we write directly now function? We can check which function we have to take. Just to show that we are calculating the left hand limit, we will write down there 1 minus. 1 minus doesn't mean that value is equal to minus 1. It means we are taking that value of x which is slightly less than 1 there. So out of these two functions, which one we will take? X is smaller than 1. So for all the values of x which is smaller than or equal to 1, our function is 1 plus x square. So just write down the function will be equal to 1 plus x square. Now just in place of x substitute 1. Then what will be the left hand limit? Yes, we will get the left hand limit is equal to 2. Now we will calculate the right hand limit. Right hand limit x tends to 1 plus there. For all the values of x which are greater than 1, what is the function? Yes, we have the function 2 minus x. So just write down there 2 minus x. Now in place of x substitute 1. What will come? Yes, we will get the answer is equal to 1. Means left hand limit not equal to right hand limit. Means when the value of x is approaching to 1, we are getting two different values for f of x, which means the limit at that point does not exist. So just write down here limit x tends to 1, f of x does not exist. The limit will exist if both left hand limit and right hand limit are equal. Okay. Now the next question. In third question it is given, evaluate limit x tends to 0, f of x, where f of x is equal to mod x by x if x not equal to 0, and it is equal to 0 when x equal to 0. The function is defined in this way that when the value of x equal to 0, we have f of 0 equal to 0. And when x not equal to 0, now here we have to specify it more. When x not equal to 0 means x can be positive or x can be negative there. Correct? So we can just rearrange this term there. When x not equal to 0 means x can be greater than or equal to 0 or x can be less than 0. Since modulus is there, we can simplify this modulus function there, because rest everything is same there. When x is greater than or equal to 0, we are taking mod x as x only, correct? But when x is less than 0, when x is less than 0 means x is a negative number. X is already negative. So we are defining mod x as minus x. So don't think that modulus will be negative there. Here our x is a negative number. Suppose I am taking minus 3. So modulus of minus 3 will be equal to minus of minus 3. Then we will get there plus 3. That's why always we are saying that modulus function is positive. So if x greater than or equal to 0, we have to take mod x as x. And if x is less than 0, then we will take mod x as minus x. So now we are just rearranging that function. F of x is equal to, first condition we are taking when x is less than 0. We wrote there in place of mod x, what we have to write? When x is less than 0, minus x. So our function will be equal to minus x by x. When x equal to 0, what we have? 0. And when x is greater than or equal to 0, here we don't want, because in this condition it is given. So when x is greater than 0, mod x is x. So we will get here x by x. So just we have rearranged the given question in this way, so that it will be easy for us to calculate the left hand limit and right hand limit. Now we will calculate the left hand limit at x equal to 0. So left hand limit means limit x tends to 0 minus, which function we will take when value of x is less than 0? This is our function, that is minus x by x. What will come? Both will get cancelled. We will get the answer is equal to minus 1. Now we can check what will be the right hand limit. Right hand limit, what will come? Limit x tends to 0 plus. For all the values of x which are greater than 0, this is our function, x by x. So x and x will get cancelled. We will get the answer is equal to 1. So what we are getting? Left hand limit not equal to right hand limit. Left hand limit not equal to right hand limit. Therefore, limit x tends to 0, f of x does not exist. Just to write down in words there. Limit x tends to 0, f of x does not exist. Clear? Okay. Now we can take the next question. The next question is evaluate limit x tends to 3 mod x plus 2. Now just to check here. Here condition is not given. When x is less than 0 or when x is greater than something, no condition is given. So whenever question is given in this way, you don't have to do anything. What you have to do? Just substitute in place of x the given value there. Then what will come when we will substitute? Modulus of 3 plus 2. So we will get here modulus of 5. And what is the value of mod 5? Mod 5 is 5. So answer will be equal to 5. Okay. Now next question. Question number 5. In question number 5 it is written, if f of x is equal to mod x plus 1 if x less than 0, and it is equal to 0 if x equal to 0, and it is equal to mod x minus 1 if x greater than 0. Question is, for what value of a does limit x tends to a f of x exist? Write down there. For what value of a does limit x tends to a f of x exist? Now here we have to check for what value of a limit x tends to a f of x exist. Condition is given in this way only. So again we can just change this condition there. Here we know if x is less than 0, then mod x can be written as, yes, mod x can be written as minus x. So we will write down there minus x plus 1 if x is less than 0, and it will be equal to 0 if x is equal to 0, and if x is greater than 0, modulus x will be equal to x only. So we will get there x minus 1 if x is greater than 0. So the given question we have just rearranged in this way so that it will be easy for us to calculate there. Now here we have to find out the values of a. So a can be 0 or a can be greater than 0, less than 0 also. So first condition we will take, let a be a real number. Let a be a real number greater than 0. Let a be a real number greater than 0. So a be a real number means we are taking that values which are greater than 0. So from all these, if the value of x is greater than 0, which function we will take? Our function will be equal to x minus 1. F of x is equal to x minus 1. Now just write down there, limit x tends to a, f of x will be equal to limit x tends to a, in place of f of x what we have? X minus 1. So just substitute in place of x a. So we will get there a minus 1 which is equal to f of a. So when we have taken a is a real number greater than 0, what we are getting? Limit x tends to a, f of x equal to f of a, which means the function is continuous for all the values of a which are greater than 0. In the same way we will check for the second case. Let a be a real number. Let a be a real number less than 0. Then out of these three functions, which one we will take? If it is less than 0, our function is minus x plus 1. So function is minus x plus 1. Again write down there, limit x tends to a, f of x is equal to limit x tends to a. In place of f of x we have here minus x plus 1. Now in place of x substitute there a. Then we will get there minus a plus 1 which is equal to f of a, which means the function is continuous for all the values of a which are less than 0. So we checked the continuity, we checked the limits for x less than a less than 0 and a greater than 0. Now we have to check for a equal to 0. At a is equal to 0, first we will check the left hand limit. At a is equal to 0. Left hand limit. So limit x tends to 0 minus. Which function will come? Yes, this one will come, which is minus x plus 1. So just to substitute x equal to 0, what will come? We will get the left hand limit is equal to 1. Similarly, we will calculate the right hand limit also at a is equal to 0. Then we will get their limit x tends to 0 plus. Which function we will take? Yes, we will take the function x minus 1. So just to substitute x equal to 0, what will come? We will get the limit, answer minus 1. Left hand limit is plus 1, right hand limit is minus 1. At which point? At a is equal to 0. So rest for all the values we are getting the limit exist. But in this case what is coming? Left hand limit is not equal to right hand limit. So just write down there, limit x tends to a, f of x exist. Limit x tends to a, f of x exist for all the values of a except a equal to 0. Okay. Limit x tends to a, f of x exist for all the values of a except a is equal to 0. Okay. Now we can check the next question. Question number 6. In question number 6 it is given, if f of x is equal to x minus mod x by x, if x not equal to 0 and it is equal to 2 if x equal to 0. We have to prove limit x tends to 0, f of x does not exist. Question is, show that limit x tends to 0, f of x does not exist. So once again what we will do, we will just rearrange the question there, because we have to take the condition when x greater than 0 and when x less than 0. So shall we write directly there? Okay, first condition is if x less than 0. So just to tell me, if x less than 0, if x less than 0, which function we will take? Modulus of x will become, yes, mod x will become minus x. Then what will come? X minus x by x only. Then x plus x will be equal to 2x. Then we will get there 2x by x if x is less than 0. And if x is equal to 0, already we have the function 2 there. Now next case is when x is greater than 0. When x is greater than 0, mod x is x only. Then what will come there? X minus mod x by x, or you can write down there this is equal to 0 there. If you want, you can simplify here only. Here x and x will get cancelled, we will get here x, the value equal to 2 there. So when we have rearranged, we are getting in this way. F of x is equal to 2 if x is less than 0, equal to 2 when x is equal to 0, and it is equal to 0 when x is greater than 0. We have to check the limit at x is equal to 0. So now we are calculating the left hand limit, that is limit x tends to 0 minus. So can you tell me out of these three which value we have to take? Yes, we have to take 2 there. We don't have to substitute here x because x is not there. So our answer is equal to 2. Left hand limit is equal to 2. Similarly, we will check what will be the right hand limit. So just write down there limit x tends to 0 plus there. Which function we will take? Yes, for all the values of x which are greater than 0, our value is 0. So what will be the right hand limit? We are getting the right hand limit equal to 0. So just write down there left hand limit not equal to right hand limit. Therefore, limit x tends to 0, f of x does not exist. Clear? Okay. Now we can check the next question. In the next question it is written, if the function f of x satisfies limit x tends to 1, f of x minus 2 by x square minus 1 equal to pi. Then evaluate limit x tends to 1 f of x. It is given the function satisfies this one. Then we have to evaluate limit x tends to 1 f of x. Here we are not checking what is limit x tends to 1 f of x. Now we know limits can be written separately there. So we are going to write down the limit separately. Limit x tends to 1 f of x minus limit x tends to 1 2 by, in denominator also it can be written separately, limit x tends to 1 x square minus 1. Here I haven't written separately because it is a polynomial function there. Here we have to calculate limit x tends to 1 f of x. That's why written here separately, equal to pi. Now this expression we can shift to right hand side. Then what will come? Limit x tends to 1 f of x minus limit x tends to 1 2. Here we don't have any term of x. So we don't have to substitute x equal to 1 there. Directly we can write down there 2 equal to pi into limit x tends to 1, limit x tends to 1 x square minus 1. So from here we will get limit x tends to 1 f of x minus 2 is equal to. Now just to substitute x equal to 1, what will come? 1 minus 1, 0. Pi into 0, 0. So our right hand side will become 0. We have to calculate limit x tends to 1 f of x. So this 2 we can shift to right hand side. Then we will get there limit x tends to 1 f of x equal to 2. Okay. Now we can check the next question. Question number 8. In question number 8 it is given if f of x is equal to mx square plus n, if x less than 0, and x plus m, if 0 less than or equal to x less than or equal to 1, and it is equal to nx cube plus n if x greater than 1. Question is, for what integers m and n does both limit extends to 0, limit extends to 0 f of x and limit extends to 1 f of x exist? For what integers m and n does both limit extends to 0 f of x and limit extends to 1 f of x exist there? Now you can check here. In this question, 3 functions are there. This question is a combination of 2 questions there. Okay. First one is, for all the values of x which are less than 0, we have to take this function there. Then for all the values of x which are greater than 0, we will take this function, and after that for all the values of x which are less than 1, we will take this as function, and for greater than 1, this one. So when we will calculate the left hand limit and right hand limit, then it will be clear to you. Okay. So now first we are checking limit extends to 0 f of x. So first one, left hand limit. Limit extends to 0 minus means our value of x is slightly less than 0. So for all the values of x which are less than 0, which is our function? Yes, our function is mx square plus n. Now what we will do? Just substitute x equal to 0. Then what will come? We will get the value is equal to n there. Now we can calculate the right hand limit for x equal to 0. Then it will be equal to limit x tends to 0 plus. Which function we have to take? For all the values of x which are greater than 0, our function is nx plus m. nx plus m. When we will substitute x equal to 0, we will get the answer is equal to m there. Now it is written. We have to find out the condition for which limit extends to 0 f of x exists. We know limit extends to 0 f of x will exist. Just write down there. Will exist if left hand limit equal to right hand limit. What is our left hand limit? N equal to m. So limit will exist if n is equal to m. So the first part is over. Limit extends to 0 f of x condition should be equal to n is equal to m. Now similarly we can check for x is equal to 1. So now at x is equal to 1 we are checking the left hand limit. Left hand limit means we are taking that value which is slightly less than 1. So for all the values of x which is less than 1, our function is nx plus m. nx plus m. Now just to substitute x equal to 1. Then we will get there n plus m. Similarly, we will calculate the right hand limit. Right hand limit means limit extends to 1 plus there. So which function will come? Yes, this one will come. That is nx cube plus m. So now just to substitute, then we will get there n plus m only. So now just to check, both are equal there. When we have calculated the left hand limit and right hand limit at x is equal to 1, we are getting the values are equal. So you can write down there limit x tends to 1, f of x will exist for all the values of m and n. Clear? Okay. Now we can check the next question. In the next question it is written, suppose f of x is equal to a plus bx if x is less than 2, equal to 5 if x is equal to 2, and it is equal to b minus ax if x is greater than 2, and limit x tends to 2, f of x is equal to f of 2. What are the possible values of a and b that we have to check? So this condition is given, we have to find out the possible values of a and b, and this is the condition given. Limit x tends to 2, f of x equal to f of 2. What does this mean? Yes, this means left hand limit and right hand limit both are equal and both are equal to f of 2. So this expression means left hand limit equal to right hand limit equal to f of 2. Okay. So now left hand limit is also equal to f of 2. Right hand limit is also equal to f of 2. So now first we can calculate what will be the left hand limit. We are checking the left hand limit at x is equal to 2. So x tends to 2 minus. Can you tell me which function we will take? Yes, we will take this as the function, because for all the values of x less than 2, our function is a plus dx. Now just to substitute x is equal to 2. What will come? We will get there a plus 2b. Now we will use this condition there. Left hand limit is equal to f of 2. What is f of 2? When x is equal to 2, we have f of x is equal to 5. Means f of 2 equal to 5. So our first equation will come a plus 2b is equal to 5. Now we can check the right hand limit. Right hand limit means we are taking that values of x which are slightly greater than 2. So which function we will take? Yes, we will take the function b minus ax. Now just to substitute x is equal to 2, then we will get there minus 2a plus b. So again we will take this condition, minus 2a plus b is also equal to f of 2, which means minus 2a plus b also is equal to 5. Now we have two linear equations there. We can solve the linear equation. So I think we can make the coefficient equal. So we can multiply the first equation by 2. Then we will get there 2a plus 4b is equal to 10. And here it is minus 2a plus b is equal to 5. Just add the two equations, then this one will get cancelled. 4b plus b is equal to 5b is equal to 15. Then we will get there b is equal to 3. Now you can substitute the value of b in any one of the equation to get the value of a. So suppose I am substituting in second equation, that is minus 2a plus 3 is equal to 5. Then we will get minus 2a is equal to 5 minus 3 2. Then our answer is equal to a is equal to minus 1. Is it clear? Okay. Now we can check the next question. Question number 10. In question number 10 again the function is defined as f of x is equal to 3x by mod x plus 2x if x not equal to 0, and it is equal to 0 if x is equal to 0. We have to show that limit x tends to 0, f of x does not exist. Okay. So again we can rearrange the question. We will take the first condition when x is smaller than 0. If you want, you can do the rough work here and directly you can write down the function. We know if x is less than 0, mod x will be equal to, yes, mod x will be equal to minus x. So just to check, if we will substitute mod x is equal to minus x, what will come here? Minus x plus 2x. Then we will get there 3x by 2x minus x will be equal to x. X and x will get cancelled. We will get the answer is equal to 3 when x is less than 0. And if x is equal to 0, we have the value equal to 0. Now we will check for x greater than 0. We know if x is greater than 0, mod x will be equal to x. Then function will become 3x by x plus 2x, which will be equal to 3x by 3x, both will get cancelled, we will get here 1. If x is greater than 0. Now we can write down there, left hand limit is equal to limit x tends to 0 minus, which one we will take? Yes, we have to take here the function is equal to 3. Then left hand limit is equal to 3. Now we can check the right hand limit. Right hand limit is equal to limit x tends to 0 plus. This calculation became easy because before only we specified the function there. So in this way if you will do, calculation also will become easy for you. Okay, which one we will take? 1. So our right hand limit is coming equal to 1. So just write down there, left hand limit not equal to right hand limit. Therefore, limit x tends to 0, f of x does not exist. So I hope whatever questions we discussed today, these questions are clear to you. Okay, so all of you note down your homework. Your homework will be exercise 13.1. Exercise 13.1, question number 23, 24, 26, 27 and 28. 23, 24, 26, 27 and 28. In between whatever questions are there, that questions we have discussed here. Okay, so all of you do the homework and in case of any doubt you can ask. Thank you.